welcome to Sri Sathya Loka Seva Gurukulam online classes. We've been doing limits and continuity. We'll continue with the same. This is class number 3. So we've been evaluating and finding the value of limits. Okay. Now, if we consider this particular question wherein we have to evaluate limit x tending to 0, square root of 4 plus x minus square root of 4 minus x by x. So the value of this function at x is equal to 0 is basically what we are trying to see. If I substitute 0 in place of x, what do I get? I get root of 4 plus 0 minus root of 4 minus 0 divided by 0. So this becomes root 4, that's 2, minus root 4, that's also another 2, by 0. So this is 0 by 0. So this is an indeterminate form, meaning we are unable to find out what happens to the behavior of this particular function at x is equal to 0, right? We've been discussing such conditions in the previous classes too. So now let's see how to solve it. So now we have to do something, rearrange the equation so that when we substitute the limit value, it shouldn't be taking us to indeterminate value, but it will give you a number to determine what the limiting value is. So what do? So whenever we have irrational functions like this, either on the numerator or on the denominator, we would have to rationalize it. So now I can see that I have an irrational function on the numerator. So I'm going to rationalize it. So how do I rationalize? I multiply by the conjugate of this particular irrational function. So what do? Limit x tending to 0. You would have dealt with irrational numbers in grade 9. You know how to rationalize an irrational number, right? So you need to multiply by its rationalizing factor. Now what is the rationalizing factor of root of 4 plus x minus root of 4 minus x? The rationalizing factor would be root of 4 plus x plus root of 4 minus x. When I multiply these two, it becomes a plus b into a minus b. So it's as good as a square minus b square, meaning I will be squaring this and then squaring this. So wherein it gets converted into a rational number. So whatever I do, I cannot just do it to the numerator of the function. You all very well know that you can convert any fraction into its equivalent fractional form, meaning whatever you multiply to the numerator, you will be multiplying to the denominator also. Nullifying, therein making no change to the number. I'm just rewriting the function, that's it. So this is as good as the previous function. I have not made any changes. I'm multiplying equal quantities onto the numerator and the denominator, right? So I'm choosing the rationalizing factor of it so that I get rational numbers to help me substitute my limits. So when I multiply these two, what do I get? This is a minus b into a plus b. So this is a square. So wherein my a is root of 4 plus x, a square minus b square. My b is root of 4 minus x divided by x into root of 4 plus x plus root of 4 minus x. So when I simplify, what do I get here? This is equal to limit x tending to 0. So the square and the square roots gets nullified. I get 4 plus x minus, here again it gets nullified. I get 4 minus x. So there's minus outside. You know how to subtract two algebraic functions. So put them in brackets so that you don't do any mistakes while operating on it. So this is x into root of 4 plus x plus root of 4 minus x. So this is equal to limit x tending to 0 I have like variables there, so I can add them up. So this is 4 plus x. Since there is a minus outside, I'm removing the brackets by changing the signs of the terms inside. So these things are basics you would have learned in your junior classes. So when I simplify this 4 and 4 gets cancelled out, and I have x plus x, that is equal to 2x. So limit x tending to 0, 2x divided by x into root of 4 plus x plus root of 4 minus x. Now my challenge was that it was taking me to indeterminate format, wherein I was getting a 0 on the numerator and on the denominator. So what gave me a 0? This minus was basically the problem. It was equal quantities on both sides, so this gave me a 0. And again, this x was a problem when I substituted x is equal to 0. See, my problems are getting sorted out because this x and x gets cancelled. So the new denominator x has gone, and on the numerator there is no minus, and on the denominator also it has got converted into plus. So when I substitute 0 now in place of x, what do I get? On the numerator I don't have an x at all. So on the denominator 4 plus 0 is root of 4. That is 2 plus 4 minus 0, it's root of 4 again, that's again 2. So I have 2 by 4, and this is equal to 1 by 2. So limit x tending to 0, root of 4 plus x minus root of 4 minus x by x is equal to 1 by 2. Okay, so when x is 0, this function takes a value of half. Hope you've understood. We'll move on to the next question. Okay. So the next question, question number 2. Here if you observe, it says limit x tending to 2, root of 3x minus 2 minus x by 2 of 2 minus root of 6 minus x. Okay. First, let's substitute the limits and see what we are getting. If you get a direct answer, well and good, we can find the limits easily, evaluate the limits easily. So when I substitute 2 in place of x, this is what becomes, this is how the function turns. Let's see when I solve what answer I get. So this is root of 6 minus 2, that is root of 4. Root 4 is 2. 2 minus 2 divided by 2 minus, again 6 minus 2 is root 4, that gives you a 2 again. So here I get a 0 by 0 form. So this is indeterminate format. So I'm unable to find out what happens to the function at this point, right? So now I need to rewrite the function. So what do I do? In the previous question, what did we see? We had irrational factors. We tried to rationalize them, right? We had irrational factors on the numerator, so we multiplied by its conjugate, meaning the rationalizing factor of the numerator. But in this question, if you observe, there's an irrational number here and here, both on the numerator and on the denominator. So now what do? We'll try to rationalize both the numerator and the denominator, and then try to substitute the limit and see what happens to the function. So what is my rationalizing factor of the numerator? It's going to be root of 3x minus 2 plus x, okay? So whatever I do, I cannot just do it to the numerator. I need to do it to the denominator also. So what do? I multiply the denominator also by root of 3x minus 2 plus x. Now I don't want to stop here. I want to rationalize the denominator also. So I'm going to multiply by the rationalizing factor of the denominator too. So I'll do it to the numerator and to the denominator. So I'll multiply by 2 plus root of 6 minus x divided by 2 plus root of 6 minus x. Now let's try to simplify this. This looks a little complicated, but we'll smartly split the function so that it becomes a little easier for us. Okay, so we will club the factors to its to its rationalizing factor and multiply those two first. So, limit x tending to 2 on the numerator, I'm going to pair up this and its rationalizing factor. So, when I multiply root 3 minus x minus x into root of 3x minus 2 plus x, so this is of the form a minus b into a plus b, I get a square minus b square. So, my a is root of 3x minus 2, so I square it, minus my b is x and then I square that. So, I am left with one more factor, that's the rationalizing factor of the denominator. Let me place it just like that. I am not going to multiply that to this by, now on the denominator, I am going to pair this up with its own rationalizing factor, because I basically want to rationalize the numbers. So, I am going to pair it with its own rationalizing factors. So, 2 minus root of 6 minus x into 2 plus root of 6 minus x, I am going to multiply. 2 is my a, I am going to square that, minus my b square is going to be root of 6 minus x the whole square. And then the other factor, I am just going to keep it like that, untouched. Okay. So, now when I have two functions multiplied to itself and I am going to, when I apply limits, what happens? Let's quickly have a look at it. Limit x tending to a, f of x into g of x, meaning there are two functions multiplied to itself. It is as good as applying the limit to the first function multiplied to limit x tending to a, the second function. So, I can split the limits like this and then multiply it. So, the same thing I am going to do it here. I am going to pair these two up and then pair these two up and separate it and apply limits so that it becomes easier. Otherwise, it's going to lead us into again an indeterminate form and the question is going to go very long. Okay. So, now let's see what happens here. So, this becomes limit x tending to 2. This is 3x minus 2. When it's squared, the square root gets nullified, minus x square divided by 4 minus 6 minus x. Okay. Now, the second part of the function comes into play. Now, I have limit x tending to 2 into, so I am just separating this with the limits. So, 2 plus root of 6 minus x by root of 3x minus 2 plus x. Now, the advantage of this is not going to definitely, the second part of the function is not going to definitely lead us into indeterminate form because there is no minus in between. It is getting added up. So, definitely no zeros on either the numerator or the denominator. So, this is safe. Now, let us deal with this now. This has to be rewritten now. Let us do that. So, here I have limit x tending to 2. Okay, this is a quadratic equation. We will try to factorize it. You would have learned in your junior grades how to factorize quadratic equations. So, the equation is minus x square plus 3x minus 2 by, the denominator has 4 minus 6, that's minus 2 plus x. So, I am going to rewrite it as x minus 2. I hope you all understand this. Into limit x tending to 2. Finally, we will substitute the limits. As of now, we will keep the functions as it is. Okay. Now, what happens to this function? Now, my x square is a negative term, which I don't prefer. I will take the negative outside to make it positive and then let's factorize it. So, I am going to have limit x tending to 2 minus of x square minus 3x plus 2 divided by x minus 2 into this part of the function, limit x tending to 2 plus root of x 6 minus x divided by root of 3x minus 2 plus x. So, now let us rewrite this again. Now, I have my x squared term is negative. So it might confuse. So we will make it positive. So I'm going to take this negative outside. So I've rewritten that as minus of x square minus 3x plus 2 divided by x minus 2 into the other part of the function has been rewritten there. Hope you all understand. Now, this quadratic, let's try to factorize. So how do we factorize that? Splitting of the middle term. My product should be minus 3. I should choose two numbers such that the sum of the two numbers should be minus 3 and the product of the two numbers should be 2. Right? You all remember this? Yes. So that particular pair of number would be minus 2 and minus 1. When I add minus 2 and minus 1, I'm getting minus 3. Minus 2 into minus 1 gives me plus 2. So let me split it up, split the middle term. Limit x tending to 2 minus of x square. This minus 3x, I'm going to write it as minus 2x minus x plus 2 divided by x minus 2. And here I just rewrite it again. Finally, I'll substitute the limits. Okay, now what do I do? How do I proceed with this? I pair up two terms at a time and then try to factorize it. So what's the common number between x square and minus 2x? It's going to be x. So I take x outside. So I have remaining 1x here and minus 2 here. Similarly, between these two, I don't see any common factor. So I'm going to take minus 1 outside. So it becomes x minus 2 divided by x minus 2 here into, so just rewrite this function again. Okay. So now let's continue with this. So this becomes limit x tending to 2. Again, these two, between these two, I have x minus 2 common. Let me take it out. So I'm left with x here and minus 1 here. And I have a x minus 2 here. And this gets carried forward. Now look at this. This x minus 2 was our hindrance. This is the one that gives us 0 when we substitute 2 here. So now this gets cancelled out. So we are really sure that it's not going to lead us to a 0 by 0 format. And again, this also will not lead you into a 0 by 0 format. Now it's ready for the substitution of limit into the function. So now let's substitute and see. So it's limit x tending to 2. I'm just left with x minus 1 and then into limit x tending to 2. I'm left with the other function there. Let me rewrite it a little later. First, let me substitute this particular limit here. So x takes the value of 2. I have 2 minus 1 into, now I'll write this, limit x tending to 2. What's the second part of the function that's there? 2 plus root of 6 minus x by root of 3x minus 2 plus x. So when I substitute 2 here, now 2 minus 1 is 1 into this one also, let me substitute the limit. So I have, let me write it again. So this is 1 into, when I substitute here, it's 2 plus root of 6 minus 2 divided by root of 6 minus 2 plus 2. So this is 1 into 2 plus root 4, that's 2. 2 plus 2 is 4 divided by root of 4, that's 2. 2 plus 2 is again 4. So this is equal to 1. So this is the answer that we get. But one place we might have made a mistake. This negative is outside. I have not carried it forward. So there is a negative here. There is a negative sign here outside. There is a negative sign here. So now there is a negative sign here. So this is minus 1 and the final answer is minus 1. I hope you all understand. Now, at any point in time, you can start substituting the limiting value. So now after this step also, here you can substitute and make it a number and then proceed with this simplification, or finally together also you can substitute the limits as how we did now. Okay. So this is one method wherein you can solve it. You can try at your leisure Try if you have other methods with which you can solve this question. Okay. So now let's move on to the next question. Next question for this class is limit x tending to 2, 1 by the absolute value of x plus 2. So till now we were looking into the irrational functions. So we rationalized and tried to substitute the limits. Now here, when I substitute the limit and see, it gives you a proper number. See, if you see, if I substitute 2 here, it gives you 1 by 4. But that's not the way to deal with absolute value functions. Because absolute value functions act differently at different values. So let's first understand how it behaves, in which interval it behaves how. Okay? Okay, so this is absolute value. What is an absolute value? Let's suppose I consider absolute value of 2. My absolute value of 2 is going to be 2. The absolute value of minus 2 is also going to be 2. So this is basically the distance of a number from 0. So distance will not be attached to any sign, right? So minus 2 is going to be 2 jumps away from 0, but on the left hand side. Wherein your plus 2 is going to be 2 jumps on the right hand side. So ignoring the side, it's basically 2 jumps. So that is what we are looking into. The absolute value talks about only the value and not the sign, right? So now, how do you define this function? So in different values, this function is going to behave differently. So now we've learned what is absolute value of a number. Now let's take this function and understand what happens to it. Now, when this function is negative, when will it be negative? This function, if you take the variable function, the equation rather, the expression there, equate it to 0, and then find the value of x. So, x gives you minus 2. Now, this is the solution for the expression that you have there, right? So, now observe it. Now, when I substitute minus 2 here, what happens? 1 by minus 2 plus 2, absolute value of, right? So, that is nothing but 1 by absolute value of 0. Now, the distance of 0 from 0 is 0 only. So, it is 1 by 0. It's going to be infinity. So, there is no change. It's going to give you the same value. Now, when I put a number more than minus 2, okay, so let me choose a number. See, let me draw the number line. So, minus 2 is my solution. I am observing the behavior of this particular function after minus 2 and before minus 2. Is there any change? Okay, is there a change in its behavior? So, first let's look into the right side of minus 2. So, right side of minus 2, I'll have minus 1, 0, 1, 2 and all this on the number line. Let's choose a random number. Let's choose minus 1 and substitute in place of x and see what happens. So, it becomes 1 by absolute value of minus 1 plus 2. So, this is 1 by absolute value of 1, that is 1 itself. So, there is no change because absolute value of a positive number, I am not doing any change to it, I am just taking the number itself like that, right? So, on the right hand side, this function does not have a big change. So, let me first define the function now. So, f of x is going to be equal to 1 by x plus 2 without any changes to it when x is greater than or equal to minus 2. So, equal to minus 2 also I did not do any change, and equal to greater than minus 2 also there was not much change to the function when we substituted those values. Now, we will observe the function in this area where the value is somewhere less than minus 2. So, we will take a random number and see what happens to the function. I take minus 3. Let's substitute there. So, it becomes 1 by absolute value of minus 3 plus 2. So, that's nothing but 1 by absolute value of minus 1. Now, what's absolute value of minus 1? It is plus 1. So, here I am doing a change. This minus 1 gets transformed to plus 1. But here there was no change at all. So this is 1 now. If the function was with brackets, let's see, observe that. If it was just brackets, it would have been minus 3 plus 2, minus 1. But with the modular sign, it's changed its sign. So there is a change of behavior of this function on the left hand side of minus 2. So basically what happens? It is negative of 1 by x plus 2. So when you put normal brackets, whatever value you get, on that value, if you change the sign, meaning you put a negative on outside, you get the value of this absolute value function. Am I right? So this is the definition of the function when x is less than minus 2. So how do we do this? In short, I'll quickly recap. Take the algebraic expression that's given in the function inside the absolute value, equate it to 0, find the value of x. So now observe the function beyond that particular value and below that particular value and on that value, and redefine the function the way it behaves. Okay, so this is the new definition of the function. So let's quickly erase it and write only the definition now. So f of x is going to be 1 by x plus 2 when x plus 2 when x is greater than or equal to minus 2, and f of x is going to be equal to minus of 1 by x plus 2 when x is less than minus 2. We are asked to evaluate the limit. So how do you basically evaluate? You find the function value at x is equal to 2. Now at x is equal to 2, what is my function? So when x is greater than or equal to minus 2, my function is this. Correct? So at limit x tending to 2, my function will be this. Because greater than minus 2 is 2. So obviously my function is going to be this. I'm going to find the value of this alone. So when I substitute it, I get 1 by 4. This is my limit value. I hope you understand. Okay. So we'll move on. So this is how you'll have to deal with the absolute value functions. Okay. So moving on to the next question. You are asked to find the left hand and the right hand limits of the function. So here not only the limiting value, you are supposed to do the left hand limit and the right hand limit of the function. So to give you a quick recap of what is left hand and the right hand, we've already seen in previous videos. So we are approaching the value from left and from right. Correct? So let's quickly see with the formula I'll give you. So we have to find the left hand limit. Now what is my limiting value? At what value should I evaluate the limit? Because nowhere it is mentioned, right? But here it is given as x tends to 1. Sometimes this is also not given in the question. So with this change in the function behavior, you need to determine which value to find the limit at. Okay, so but here it says x limiting to 1. So let's take that. So now I'm supposed to find the limiting value. So first let me find the LHS, the left hand limit, LHL. So the left hand limit, that is limit of the function value from a number less than 1, 1 minus from the left hand side is equal to, of f of x is equal to limit h tending to 0, f of a, your a is 1 here, 1 minus h. From a number less than 1. So what number? It's a very small number that we are considering it as h, that is almost equal to 0. So how do I do that now? So limit h tending to 0, f of 1 minus h. Now what is my function? I need to see. I'm looking into a number that is less than 1. So less than 1, my function is defined as whenever my x is less than or equal to 1, this is my function value. So my f of x is this. So let me put it here, limit h tending to 0. My f of x is this. I'm talking about f of 1 minus h. So instead of x, I will write 1 minus h plus 3. Okay, so let's quickly evaluate that. So my h is 0. I'm going to substitute directly. 2 into 1 minus 0 plus 3. So this is minus 2 plus 3. That is equal to plus 1. I'm getting a determinate value, so I can just determine that and leave it here. So my limit, left hand limit is 1. Okay, now I'm going to look into the right hand limit. So what's my right hand limit? So I'm going to find the limit x tending to a number that is greater than 1. 1 plus f of x. So how do I rewrite that? That is equal to limit h tending to 0. F of 1 plus h. A number that's slightly greater than 1, that slightly is h, and that h is very negligible, that's almost equal to 0. So what do I do now? My f of x. Now let me see what's my function. It's greater than 1. I'm looking into the right hand side of 1, a number that's greater than 1. So whenever my x is greater than 1, my function value is 3x minus 5. So I'll take that function here. So my h tending to 0, my function is 3x minus 5. So 3 into, this is f of 1 plus h. So in the place of x, I will write 1 plus h minus 5. So when I substitute the h as 0 here, 3 into 1 minus 5, and I get minus 2. So this is my left hand limit. Okay, so does my limit exist? It does not exist, because from the right hand side, it is tending to minus 2, and from the left hand side, it tends to 1. So the behavior is not the same. So my limit does not exist, but my left hand limit and the right hand limits I've found for the function. So I hope you understand all the questions that we discussed today. If you have any doubts, pause the video, or you can rewind, go back to the area where you've not understood. You can go through it again and again multiple times and try to understand the concept. Okay, hope it was useful for you. Thank you. Sai Ram.